In this video, we'll prove that for y equals inverse tangent of x, the equation 1 plus x squared times y2 plus 2x times y1 equals 0 holds true. Let's start by finding y1, which is the first derivative of y with respect to x. We know that the derivative of inverse tangent of x is 1 over 1 plus x squared. To make this easier to work with, let's multiply both sides by 1 plus x squared. This gives us 1 plus x squared times y1 equals 1. Now, let's differentiate both sides of this equation with respect to x. On the left side, we'll need to use the product rule, since we have a product of two functions. Using the product rule, the derivative of the left side is 1 plus x squared times the derivative of y1 plus y1 times the derivative of 1 plus x squared. Let's simplify this. The derivative of 1 plus x squared is 2x, and the derivative of y1 is y2 by definition. Substituting these in, we get 1 plus x squared times y2 plus 2x times y1 equals 0, which is exactly what we wanted to prove. To visualize this result, let's look at a graph of inverse tangent. Notice how its first derivative y1 gets smaller as x increases, and its second derivative y2 relates to this through our proven equation. And that completes our proof. We've shown through differentiation that for y equals inverse tangent of x, 1 plus x squared times y2 plus 2x times y1 equals 0.